Alright, we are going to be talking today more about dividing polynomials and finding the zeros. Alright, we have the factor theorem. It says, let f of x be a polynomial. If f of c is equal to 0, then x minus c is a factor of f of x. What that means is if you, let's say I said that x equals 5, okay? Then whatever the function is, I don't know, some ax to the 5th plus bx to the 4th plus cx plus, I don't know, 7, whatever. Some function. If I tell you that x equals 5 is a solution, okay? If I tell you that 5 is a solution, which means that if I plugged in f of 5 and I changed all my x's to 5s and evaluated it, I would end up with 0, because for 5 to be a solution means it has to cross the x-axis at 5. That ordered pair is 5, 0, which means when you plug 5 into the function for x, you get 0 when you simplify it out. Okay? So what it's saying, what it also says then, is that in this case my c would be 5. Okay? So if x equals 5, then x minus that, in other words, to get 0 back on this side, minus 5, x minus 5 equals 0. So again, we're talking the difference between what a 0 looks like in math and what a factor looks like in math. Okay, same information, two ways of talking about it. Okay, and then the only obviously thing is when we do division, okay, if you have a remainder, anything other than 0, then it's not a factor. If your remainder is 0, then whatever you're dividing by, let's call it g of x, then g of x is a factor of f of x. And think about it. If I said 12 divided by 3 is 4, take away 12, remainder 0. So it tells me that 3 is a factor of 12. It also tells me that 4 is a factor of 12, because they can divide into it without getting a remainder. The same thing is true with, the same thing is true with polynomials. Okay? So it says solve this equation given that 3 is a 0 of the function. They're telling me that x equals 3. They're telling me that this function crosses the x-axis at 3. If it crosses the x-axis at 3, that means that x minus 3 is a factor. And if I divide by a factor, I know that I'll get a remainder of 0, but something else interesting is going to happen. Let me show you what. Okay, so I know that 3 is a 0. I know that x minus 3 is a factor. You could do long division if you wanted to. I'm going to do synthetic because it's shorter. Okay, if you're going to do synthetic, you're going to put 3 in the whole. Your coefficients of the polynomial are a 2, a negative 3, a negative 11, and a positive 6. Okay, the 2 comes out, multiplies by 3, brings back 6, negative 3 eats positive 6, comes out positive 3, times 3 is positive 9, negative 11 eats positive 9, comes out negative 2, times positive 3 is negative 6, positive 6 eats negative 6, comes out remainder 0. Which it has to, or they're lying to me and 3 is not a 0. The only way something's a 0 is if you divide by it and don't get a remainder. Now here's the interesting part. What's going to happen now is that depresses, and I don't mean makes it sad and needs therapy. I mean it depresses, it decreases your polynomial by a degree. In other words, I started with a third degree function. Well, when I divide an x cubed by an x, that's going to drop it down to an x squared plus 3x minus 2, which we talked about earlier. And now I have a nice handy dandy quadratic factor. So if I set this to 0 and factor it more, I can get more factors for my function. By the way, this degree tells you how many factors you have to have for this function. There has to be 3 linear factors. I've got 1, they gave me 1. Well, they gave me a 0, which I turned into a factor. I need to find the other two, because by law, that third degree means there has to be 3 factors. And as soon as I can get the factors, I can set them to 0 and get the zeros, okay? So, to solve this quadratic, we can go back to using our quadratic tools. We could try and factor. We could do quadratic formula. We could complete the square. We could do any of our tools that we want. I'm going to factor because you need to practice. So, A times C, 2 times 2 is 4. All the factors of 4, 1 and 4, 2 and 2. 1 and 4 will make 3 if I subtract. Okay? So, sorry, let me get back to my pen. So what I'm going to do is I'm going to rewrite B as 1x and 4x, and then figure out my signs. If C is negative, if that last sign is negative, then only one of them can get the sign of B, and that will be the bully. So bully 4 is going to take the positive, which means 1 has to take the negative. Okay, so I've got my rewrite B, got my signs, copy my A and C, and now I'm at 2 by 2, GCF, GCF, GCF again. Woo! Alright, on this side, these guys have an x in common, so I'm going to pull out an x. If I divide by x, I get 2x minus 1. On the other side of the wall, they have a 2 in common, and I'm always going to take this guy's sign, so I'm going to divide by a positive 2. Divide by 2, divide by 2, I'm going to end up with 2x minus 1. At this point, you better end up with a matching bino, or you did something wrong, or it's prime and can't be factored any further. But I do have a matching bino, so my GCF again is going to be by 2x minus 1. And if I factor out 2x minus 1 from both sides, cancels, cancels, and I'm left with x plus 2. So now I have, I have x equals 3, which is as a factor is x minus 3. I just found the other two factors. I have 2x minus 1 and I have x plus 2. Okay, so those are my 3 factors. How do I get the zeros? Okay, well, like we always have, you set them to 0 and get x alone. So if I say x minus 3 equals 0, add 3, that's where I got x equals 3. To solve 2x minus 1, set it to 0, add 1, 2x equals 1, divide by 2, x equals 1/2. Okay, so there's the 0 for that one. And then my third one, x plus 2, set it to 0, minus 2, I get x equals -2. And that's the 0 that goes with this factor. So what all have we figured out? Well, quite a lot of things. Remember how I told you that you don't know, we don't have tools to factor third degree, anything higher than a second degree function. We can't factor them. I just showed you how to factor them. But up until now, we had no way to do that. We had no way to factor anything bigger than a second degree. We had no way to solve it, for crying out loud. Well, now we have a way. Now, granted, they got to give us a clue first. They've got to give us a starting point. They've got to give me one of the 3. But as soon as I can get one of them, then I can divide by it, which depresses my third degree down to a second degree. Once it's a second degree, then you can use factoring or quadratic formula. So what do I know? Well, I know that this equation, 2x cubed minus 3x squared minus 11x plus 6, can be written as x plus minus 3, times 2x minus 1 times x plus 2. If you multiply these 3 together, you will get this polynomial back. Okay, I also know that the solution In other words, the x-intercepts, in other words, where this function crosses the x-axis, is going to be at x equals 3, at x equals 1/2, and at x equals -2. And I'm going to show you, I'll show you how I did this on the calculator later, but right now I just want to show you, let me erase all my writing that's over that. Okay, I just want to show you, I'll show you how I did this later, but right now, do you see right there, there's my x equals -2. Okay, right here, that 0 is at 0.5, that's why x equals 1/2. And right here, x equals 3, there's my 0 there. Okay, cool. Alright, now I'm going to show you how to do that on the graphing calculator. So, it says use a graphing calculator to solve x cubed plus 2x squared minus 1. I don't have the tools, like, because this is a third degree, I can't just start doing quadratic formula. I can't try and do like a times c, find all the factors, rewrite b. So I've got to get a clue to at least one of them. Okay, so I'm going to use my graphing calculator, and I go ahead and go to your y equals and type in x caret 3 plus 2x squared minus 1. Okay, and then I'm going to hit graph, and you might have to adjust the window to see the entire, well, it's not going to be a parabola, to see the entire, we're expecting an S shape, so you might have to adjust the window, but I can see, I'm expecting at least 3, or not at least, but I'm expecting either 3 or 1 x-intercepts. There's a law, just kind of throwing some extra information in, there's a law that says if you, whatever degree your function is, that's the most number of times that your function could cross the x-axis, or less than that amount by 2. So because my highest degree is a 3, that means this function could cross 3 times, or if you take 2 away from 3, 1 time. Okay, but so I can see there's 1, 2, 3, but my goodness, those are really, really squished together. So that is, I need to change the window, and I want to zoom in on here. I don't need all this empty space. So I'm going to change my x's to go from, I don't know, maybe -5 to 5. And again, I really don't need all this empty space up here. I want to see this, like, does it really come up more than I can, you know, this that I can see with the naked eye there. So I want to zoom this in as well. So I'm going to pick a window. I changed my x's to go from -5 to 5, counted by 1s, and I changed my y's to go from -5 to 5 and counted by 1. So try that. And you see it stretches it out a little bit more, but it's still kind of squishy there. So I'm going to change my window again. This time I went from -5 to 5 on the x. I left that alone. But on my y's, I went just from -1 to +2. Okay, and now can you see more of that definition of those two separate intersection points? Okay, it looks like here, here, and here. Okay, so now to figure out exactly what those are, because I don't really trust my eyes, okay, we can calculate a 0. So what you're going to do is you're going to hit the second trace key. You're going to choose option 2 for 0. The calculator is going to come up and ask you for the left bound. If you're tracing this from left to right, okay, you want to get close to the x-axis without touching it. Don't touch it yet. Stop before you get there and hit enter. That will be your left bound. Then once you hit enter, the calculator is going to ask you for the right bound. So now travel past the x-intercept, the x-axis, and stop right past it and hit enter again. That will mark your right bound, and then it'll ask you to guess. We don't want to guess, just hit enter, and it'll pop up the 0. Okay, so the 0 is at -1.618034, which is not a very pretty number. Okay, but I got 2 more to go. Okay, so I do the exact same thing again. You have to hit second trace all over again. Choose 2 for 0, but now you're left bound again. Now I've already passed. I left off somewhere right here. So I want to get close to the x-axis, but stop before you touch it and hit enter. That'll mark your left bound. Then go past it. Once you pass the x-axis, stop and hit enter. That will be your right bound. And then hit enter through your guess, and it'll give you the 0, which is at -1. Okay, at that point, that one I can actually use to divide by. I'm not going to try and divide by that. Ew. Okay, and then that's not even accurate. Anytime you're looking at a decimal instead of a fraction, you don't want to use it because it's been rounded, and that's less accurate than a fraction or a whole number, obviously. But I'm going to go ahead and calculate the third one. Alright, and so I move my cursor over here. Again, you're going to do second trace and choose 2 for 0. Okay, left bound. Now you left off right around here. So now you want to get close to this 0, but don't touch it. Don't touch the x-axis. Stop before you get there and hit enter. That's your left bound. Then get past it, and that'll be your right bound. Enter through your guess, and again, that one's not a very pretty number either. But if you're told to use a graphing calculator to solve, we have all three solutions. Okay, my solution set, if I round, is -1.62, -1, and 0.62. Okay. Now, what you could do so that you get more accurate answers than those two, in other words, like fractional or radical, you would take this -1, divide by it. 1, 2, 0, -1, because the first degree is missing, right? 1 comes out, brings back -1, comes out 1, brings back -1, comes out -1, brings back +1, remainder 0. That depresses it to a second degree. If you now solved this, and it's going to be quadratic formula, you'll get these two solutions. Okay? Yeah, I think I'll actually show you that. So, x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And I get x equals -1 plus or minus the square root of 5 all over 2. And if you type this in a calculator, I promise, if you type -1 plus the square root of 5 divided by 2, it'll come out to the 0.618033999 yada yada yada. And if you type -1 minus the square root of 5 divided by 2, you'll get the -1.6180334. Okay? They're radical answers. But that's kind of the point. When the whole point of this is we can't just start off like we did on quadratics, on second degree functions, and just automatically start factoring or doing quadratic formula. But what we can do is, if we can somehow find one, they either have to tell us one, like the example I did before, or I can find one myself by looking for a 0 on the calculator. But what's going to happen is, if they don't want these decimal answers, calculating them on the calculator isn't going to help you. So that's why you find one that's whole, or at least a terminating decimal that you can write as a fraction. Divide the original function by it. That will depress it to a second degree. Then use our quadratic techniques, and you'd find the other two. There was supposed to be 3 solutions. I found all 3. Okay. So this one, it says solve the equation given that -1 is 0 of the function. They're telling me that x equals -1. There has to be 2 more because it's a third degree function. So since they gave me 1, I'm going to divide by it. So -1 goes in the hole. My coefficients are 15, 14, -3, -2. 15 comes out, times -1 is -15. 14 minus 15 is -1, times -1 is +1. -3 eats +1, comes out -2, times -1 is +2, 0 remainder, which it better be, or they're lying to me, and that's not a 0. So that's dropped me from a third degree down to a second degree function. Sorry. Okay, so now if I solve this one, 15x squared minus 1x minus 2, if I factor that one now, I could get the other two factors, and then I can get the other two zeros from that. So my factoring technique here is going to be a times c, so 15 times 2 is 30. Factors of 30, 1 and 30 will not make 1. 2 and 15 will not make 1. 3 and 10 will not make 1. 4 doesn't go into 30. 5 and 6 will make 1. So I have to rewrite b as a 5x and a 6x. All I have to do is figure out my signs. C is negative, which means only the bully gets to be the middle sign. Since my middle sign is negative, then 6 wants to be negative, and 5 is going to have to be positive. Okay? So we rewrote b. Drop your a, x squared, and your constant on the end. Okay? And now we're at 2 by 2. GCF, GCF, GCF again. Woo! Alright, I can pull a 5 and an x out of this side. So if I divide by 5x, I get 3x plus 1. On the other side, I can divide by 2, and I'm going to pick the negative because that's the first sign after the wall. So my GCF on this side is a negative 2. What I get when I divide by it is positive 3x plus 1. GCF again, my matching bino is 3x plus 1. If I divide by 3x plus 1, what's left is 5x minus 2. So if I now set these to 0, those are my other two factors. Remember, them telling me that x equals negative 1 is also giving me the factor of x plus 1 equals 0. Yes? Okay, so now I have this factor, 3x plus 1, and I have the other factor, 5x minus 2. Okay, so again, once you have zeros, you have factors. Once you have factors, you can turn them into zeros. You can go back and forth between the two however you like. So those are my three factors. Now I've already got this solution, right? So if I could rewrite my function as x plus 1 times 3x plus 1 times 5x minus 2. This is the exact same thing as if I multiplied these back together, I'll get 15x cubed plus 14x squared minus 3x plus 2. So there's my equation in factored form. My solutions, my zeros are, again, you take each of these factors, set them to 0, and solve. So I would minus 1 x equals negative 1. Take 3x plus 1, set it to 0 and solve it. Minus 1, 3x equals negative 1. Divide by 3, divide by 3. X equals negative 1/3. And if I take 5x minus 2, set it to 0 and solve it. Add 2, 5x equals 2. Divide by 5, divide by 5, x equals 2/5. Those are my three factors. Those are my three zeros. Okay? And again, if I show you on the graphing calculator, there's my negative 1. Negative 0.33333333 is negative 1/3. And 0.4 is 2 divided by 5. Okay? Type in the calculator if you don't believe me. Alright, so this one again says solve the equation given that negative 1 is a 0. Okay, by hand, what you would do is you would take your negative 1. Well, I animated this. Let me see where this all comes out. Okay, on the graphing calculator, you type your equation into y equals. You get a graph that you can see again, I'm expecting as at most 3 intersection points, and I can see them. but it's squishy. So I'm going to change my window a bit, and now I can see them pretty clear. And you can see that it does cross at -1. It also looks like it's crossing at -2, and I don't know about that one because that one's in between. It's not on a ticky mark. Okay, so to figure out the other ones, again, you could go ahead and do the whole calculate zeros and do that. If you were doing it the way we did it last time, you would put -1 in the hole, 15, 14, -3, -2. 15 comes out, brings back -15, comes out -1, brings back +1, comes out -2, brings back +2, comes out 0. And we did factor this, didn't we? Okay, so this would drop me down to a second degree, -1x minus 2. Yeah, we did. Oh, I think I'm just showing you how to do it on the calculator, maybe. Remember, we got our -0.3 repeating and the 0.4, I think. Let's see. Okay, so now I can use a table of values. Oh, that's what I was going to show you. You can do it by calculating zeros, or you can use a table of values. This is on many exams. They want to know that you know this principle. So if I look at a table of values, okay, I can look at, I'm approximating by eye. I can see one for sure is at -1. It looks like there's one between 0 and -1. And this one is between 0 and 1, obviously. Well, let's go to table and see what we can see. So I'm going to go to table set, and I'm going to set it at -2. Table set is above the window key. So if you hit second window, it'll take you to setup. And I started at -2, and I'm counting by ones. Okay, so then if I look at my table of values, go back to hit second graph, you can see your values. What you're looking for, obviously, what you want to see, if you've got a great table, is you are looking for zeros in the Y column. Okay? When you have zeros in the Y column, you have found zeros. Okay? So, I know right here from this table that it's telling me that x equals -1. There's one of my solutions. Okay? But where's these other ones? The fact that I don't see any more zeros here tells me that they're not landing on any of these integers. Integers are whole numbers, no decimals, no fractions. Okay? But so how am I going to figure it out? Well, this is the cool thing that they test you a lot on tests. Okay? Remember the intermediate value theorem that we just talked about yesterday, or I don't know, whatever day it was. Okay? We talked about that if your y values change sign, then you've had to cross it over the x-axis, which means you've had to have found a zero. There's got to be a zero somewhere in there. Well, if I'm looking, do you see how these two ordered pairs, 0, -2, and 1, 24, if you look at the y values, this one is negative, this one is positive. So that means somewhere between 0 and 1, this function had to cross the x-axis. And sure enough, it shows me it did right there. Okay? So I know that there's going to be one between 0 and 1. That's what this tells me, this sign change right here. Okay? Now, what about, there's my second one. Now, what about my third one? Well, if I kind of, let's see, look at, oh, sorry, I'm going to point one out. So x is 0, that's definitely 1. Okay, looks like there's one between 0 and 1, again, because of the sign change. Okay, so where's the third 0? Well, let's go back to table set. I know that it's got to be, the other one was between 0 and -1. Well, between 0 and -1, I don't have a sign change. 0 doesn't have a sign. 0 isn't positive or negative. So I know it's got to be somewhere between there. So what I can do is change my table values, my scale of what I'm counting by, to a smaller amount, and then I could see more accurately in that little itty bitty space. So I went to table, I started at -3, and this time I changed it to count by 0.5s instead of 1s. So I changed it to count by 0.5s, and again, I'm looking for a sign change in the y coordinates. And sure enough, now that I changed my scale, I can see that at -0.5, my y coordinate is positive, whatever that number is, and at at 0, my y is negative. So here I've got a positive y, here I've got a negative y. Wait a minute, right? Yeah, that's the negative. So right here I've got a change in the y coordinates, which means I have a 0 between -0.5 and 0. Okay? So I have one, I'm sorry, I should write that better. I have a 0 between -0.5 and 0. Okay, now to get it exactly, well, you'd go back to the graph and just calculate the zeros. Okay, but a lot of times on tests, they'll give you table values and say approximate the zeros. Well, obviously, if you find a 0, that's one that's exact, but if you find sign changes in the y column, you haven't found exactly, but you can ballpark it and say, well, it's between here and here. Okay? Alright, so there we go. If this was me, this is what I would say my answer is, if they didn't want exact. Okay, if you were just estimating. I'd say the solution, I have one at -1, I have one between -0.5 and 0, and between 0 and 0.5. This one said between 0 and 1, but now since we broke it down, I can actually define the sign change further between here and here too. Alright, so this one says solve the equation. So again, if they don't give me anything, if they just said solve this third degree function, remember I told you, our hands are tied. We can't do anything with a third degree. They either have to give us a hint and say, here's one of them, or I have to go find one by visually finding one myself. So I typed the function in, so I went to the graphing calculator. This time I went to the table, okay? So it tells me that -1 is a 0. So now I can, since I know now one by hand, I know that x equals -1, I need to find two other ones. Okay, I can use synthetic division, -1, 15, 14, -3, -2. I think, I'm sorry, I was getting ahead of myself before. I think I understand how this is all coming together. They're giving you the same problem to look at a dozen times and show you how you can approximate zeros by going to tables. You can approximate them on the graph by going, well, I know it's around here. And algebraically, if they want exact algebraic answers, then how you can go from, well, I know it's between 0 and 1 and between 0 and -0.5. How can I get them exactly? Well, if you can get one, you can get it down to a second degree. Once you get that down to a second degree, then our old tools work. So 15 comes out, brings back -15. Comes out -1, brings back +1. Comes out -2, brings back +2, remainder 0. Constant first degree, second degree equation. And we already factored this a little bit ago, didn't we? 15 times 2 is 30. Factors of 30 that make 1 were 5 and 6. So I wrote this as 5x and 6x. Rewrite B. You're going to get this wrong if it kills you. And since C was negative, Bully gets the middle. He doesn't. Bring down the first and the last. 2 by 2. GCF, GCF, GCF again. I can pull a 5x from this side, which would leave 3x plus 1. I can pull a -2 from this side, which leaves 3x plus 1. That gives me 3x plus 1 and 5x minus 2. Okay, so now I have, if I solve this, 3x plus 1 equals 0, minus 1 minus 1, x equals negative, we already did this, x equals -1/3. Okay, solve this one, add 2, So 5x equals 2, divide by 5, I get x equals 2/5. Now as factors, this one would be x plus 1. Yes, this would be x plus 1/3, but they don't like writing it as a fraction. So, I mean, you could either just back yourself up and that factor is going to be 3x plus 1. But how they got that is this. I would get rid of this fraction by multiplying by 3. That gives me 3x equals -1. And then I would add 1, and I'd have 3x plus 1 equals 0. That's how we get the factor, but you're kind of going in circles. So the factor that goes with x equals 1/3 is 3x plus 1. And again, instead of doing the math here, back up to when I factored, and I get the factor 5x minus 2. So my function in factored form is going to be x plus 1 times 3x plus 1 times 5x minus 2. My solutions, my zeros, are x equals -1, x equals -1/3, and x equals -2/5. Okay. Alright, so you try this one, hit pause, come back when you're ready. Hopefully you got 2. If you did not, let's look at why. They're telling me that 4 is a 0 of the function. So I'm going to take 4 and put it in the hole. I'm going to write my coefficients of my function. 3, -31, +82, -24. Okay, and I'm going to, 3 comes out, times 4 is 12, -31 plus 12, -31 plus 12 is -19, times 4 is -76, 82 minus 76 is +6, times 4 is +24, remainder 0. So that depresses my third degree function down to a second degree function. So 3x squared minus 19x plus 6. Okay, so now if I factor that, I will get my other 2 zeros. I've got x equals 4 because they gave it to me. I got to get my 2 other ones. Okay, so if I factor 3 times 6 is 18. Factors of 18. 1 and 18. Hey, there we go. That will make 19. So I'm going to rewrite 19 as 1x and 18x. Signs, C is happy. C is positive. When C is positive, they both get to be like the middle, so they're both going to be negative. And I'm going to drop my 3x squared and my 6. And now I am at 2 by 2. GCF, GCF, GCF again. Woo! On this side, all they have in common is an x. If I factor out x, I'm going to have 3x minus 1. This side has a 6 in common, but I'm going to take the negative. And if I divide by -6, I get positive 3x -1. My matching bino is 3x minus 1. And what's left is x minus 6. So if I set those to 0, 3x minus 1 equals 0, x minus 6 equals 0, add 1, 3x equals 1, divide by 3, x equals 1/3, there's my second one. Add 6, x equals 6, there's my third one. And that's what they asked for. If they asked you for the factorization, you could factor this into, this one as a factor would be x minus 4. The other two are going to be, back yourself up to where you GCF'd again, it's going to be 3x minus 1 and x minus 6. Or, if all else fails, you can just do the algebra every time. Since x equals 4 minus 4 minus 4, x minus 4 equals 0, that's where I'm getting the x minus 4 from. X equals 1/3. Multiply by 3, 3x equals 1, minus 1, 3x minus 1 equals 0. That's where I got the 3x minus 1. And my last one x equals 6 minus 6 minus 6, x minus 6 equals 0. There's my x minus 6. Again, be careful what you're asked for. If they ask for zeros, you're looking for this. If they ask for factorization, they're looking for that. Okay? Alright, and if I look at the graph, there is my 6, there is my 4, and there's my 1/3. Alright, try this one. Hit pause, come back when you're ready. And hopefully you got 4. Okay, if not, let's look at what. They're telling me that 4 is a 0. So if I put 4 in the hole, my polynomial coefficients, functions coefficients, are 2, -5, -21, positive 36. Okay, 2 is going to come out. Times 4 is 8. Brings out positive 3. Goes to 4, brings back positive 12. And, sorry, I do not trust my brain when I'm recording. -21 plus 12 is -9, times 4 is -36, remainder of 0. That depressed my polynomial from a 3rd degree down to a 2nd degree. So now if I factor that, okay, 2 times 9 is 18. Factors of 18. 1 and 18 will not make 3. 2 and 9 will not make 3. 3 and 6 will make 3. So I'm going to rewrite this as 3x, 6x. C is negative, so only bully gets to be the middle, so 6 gets to be the positive, 3 has to be the negative. And first and last come down, 2x squared minus 9. And now I'm at 2 by 2. And I need to scoot over. Let me write it down here. 2x squared minus 3x plus 6x minus 9. 2 by 2. GCF, GCF, GCF again. Woo! Alright, so out of these two, all I can pull is an x. If I divide an x out, I'm going to be left with 2x minus 3. These two have a 3 in common, and I'm taking the positive. So divide by 3, I get 2x minus 3. My common bino is 2x minus 3. And what's left, if I divide both sides by 2x minus 3, is x plus 3. Set those to 0 and solve them. 2x minus 3 equals 0. X plus 3 equals 0. Plus 3 plus 3, 2x equals 3. Divide by 2, x equals 3 halves. Minus 3, x equals negative 3. And they gave me x equals 4 in the beginning. So my 3 zeros are 4, negative 3, and 3 halves. Okay? And if I look at the graph, there's my negative 3, there's my positive 4, and 3 halves is 1.5, which is halfway between 1 and 2, which is right there on the graph. Alright, so for some homework help, okay? 52 says, use synthetic division to show that 2 is a solution of the polynomial equation. So can you put 2 in the hole? 2, 2nd degree, 1st degree, constant, don't forget that 0 placeholder. And show that you get 0 for remainder. That's what A wants. B says, use the solution from part A. Well, they're telling you that 2 is the answer. So they're saying, find the dimensions of the box. Well, change all your h's to 2. So this would say h equals 2. This would say 2 times 2 is 4. This would say 2 plus 7 is 9. So your dimensions of your box is 2 by 4 by 9. Easy. Okay, in these ones, you're not solving anything. They just want you to write a polynomial that represents the length of each rectangle. They're giving you an area and a width. If area equals length times width, and I'm trying to figure out length, divide by W, length equals its area divided by its width. So they're just telling you to write that function. So I'll do 54. I have more room. So I'm going to say that the length is equal to the area, which is 8x cubed minus 6x squared minus 5x plus 3, divided by its width, which is x plus 3/4. And it didn't say solve it or find the length and the width. All it said was write a polynomial expression. Well, there you go. Okay, over here they're talking about some economist and taxes and things like that. Okay, they give you this function, which models the government tax revenue, f of x. So f of x represents the revenue that they get from taxes in tens of billions of dollars in terms of the tax rate x. So if they give you a rate, you're going to plug it in for x. The graph of the function is shown. It illustrates tax revenue decreasing quite dramatically as the tax rate increases. At a tax rate of, gasp, 100%, the government takes all our money and no one has incentive to work. With no income earned, $0 in tax revenue is generated. Okay, so it's for A, it says, find and interpret f of 40. Identify the solution as a point on the graph of the function. They're telling you to come back up here and change your x's to 40. So plug 40 in there, 40 in there. To type it in the calculator without screwing it up, you'd go parentheses 80 times 40 minus 8,000 parentheses divided by parentheses 40 minus 110. And then it'll give you the proper answer. B says rewrite the function by using long division. So they want you to do long division on this. Then use the new form to find f of 40. So once you depress this down, once you do division, and you're going to take it down to just a constant, find f of 40, and then just see if you obtain the same answer. Okay? And it says, is f a polynomial function? Explain your answer. Well, look at the graph and see if it passes the vertical line test. Okay, so we are at homework, which means we are done. So happy homeworking, and I will see you next